Uncertainty Principle in Quantum Mechanics and Human Destiny. Xiefeng, December 5, 2023. Translation edited by Chinyo. In my article, All Our Efforts and Contributions Accumulate Virtue for Ourselves, I elaborated on a principle that suggests, according to the conservation of energy theorem, the sum of positive and negative energies in the universe is zero. This phenomenon, like as you sow, so shall you reap, can be deduced to speculate on a person's future scenarios based on factors such as their psychological activities, words, behaviors, expressions, attitudes, and postures. In other words, a person's life trajectory and destiny can be predicted. However, some have questioned this, arguing that microscopic particles exhibit random Brownian motion, and the uncertainty principle of quantum mechanics tells us that human destiny cannot be predicted. The skepticism is very valuable. Now, let's analyze and explore whether the uncertainty principle of quantum mechanics can be applied to predicting destiny. Before delving into this, let's first understand what Brownian motion, quantum mechanics, and the uncertainty principle of quantum mechanics mean. Describing scientific concepts in academic language can be challenging for the public, so I prefer simplifying complex scientific concepts for better understanding. Brownian motion refers to the random movement of particles. Most people who have studied in school have observed the erratic movement of molecules. Under a microscope, all molecules move aimlessly, colliding with each other randomly, creating a chaotic motion. What is quantum? Again, avoiding scientific jargon, let's understand quantum like this. Traditionally, energy is continuous and cannot be measured in discrete units like 1, 2, or 3. For instance, when we measure the length of an object, we can be precise to, say, 1.259264819 meters. However, many objects in the objective world can only be measured in whole units, not in decimal points. For example, if you count the number of sheep in a pen, you can't say there are 13.483256 sheep. You can only say there are 13 or 14 sheep, not 0.483256 sheep. When scientists discovered that light exhibits both particle and wave properties, thus having wave-particle duality, Max Planck found that the flow of electromagnetic energy is not continuous but occurs in discrete packets. He coined the term quantum to measure this energy packet. When sunlight shines on a metal plate, photons can knock electrons out of the metal plate, creating a flow of electrons, which forms an electric current. This phenomenon is known as the photoelectric effect. In the photoelectric effect, electrons are not excited by the intensity of light, but by the frequency of photons. Einstein discovered the particle nature of light, and the smallest unit for measuring the energy of photons is called a quantum. This wave-particle duality of light overturned traditional understanding, and the need to describe this phenomenon with concepts beyond traditional cognition led to the birth of quantum mechanics. Thus, Newtonian mechanics became known as classical mechanics, and the principles that classical mechanics cannot explain became known as quantum mechanics. Quantum mechanics explains the laws of motion of microscopic matter and represents a major leap in human cognition beyond classical mechanics. So, what is the uncertainty principle of quantum mechanics? The essence of the uncertainty principle is, strictly speaking, the principle of indeterminacy principle. Uncertainty and indeterminacy are two completely different concepts. Uncertainty implies almost negation, while indeterminacy neither affirms nor denies. The meaning of the uncertainty principle is that if the position of a microscopic particle can be determined, then its momentum, such as velocity, is difficult to determine, i.e., uncertain. Conversely, if the momentum, such as velocity, of a particle can be accurately measured, then the position of the particle is difficult to determine or uncertain. In classical mechanics, knowing the velocity and time allows for the accurate determination of position. However, in quantum mechanics, even if the velocity and time are known, the position cannot be determined, and the more accurate the velocity and time values, the more difficult it is to determine the position. Photons or electrons, are they appearing in wave form or particle form? This is difficult to determine because they are in a superposition state. Only when an observer appears will they present a certain fixed form. Without an observer, it's difficult to determine whether they are particles or waves. In order to explain and resolve this dilemma, the concept of Schrödinger's cat was born. The cat locked in a sealed box could be alive or dead. It's impossible to determine whether the cat is alive or dead before opening the box. Only when an observer opens the box can the cat's state be determined. Before it's determined, it can be said that the cat in the box is both alive and dead. Schrödinger believed that the cat is either dead or alive. The state of being both dead and alive does not exist. Therefore, Schrödinger denied the superposition state of being both dead and alive. Based on this, an American scientist introduced the concept of parallel universes. He believed that the superposition state does not exist at all, not because the observer's presence collapses the superposition state, but because it splits. Seeing the cat alive is in one real world, while seeing the cat dead is in another real world. The wave-particle duality principle is the same. In one real world, the electron you see is in wave state, while in another real world, the electron you see is in particle state. Or it can be said that one person sees the cat as dead, while another person sees it as alive. Who is wrong? Neither, because the two people are in different worlds, and the forms of the macrocosm they see are different. Having understood Brownian motion, quantum mechanics, and the uncertainty principle, let's reevaluate the validity of the law I propose that all our efforts and contributions are to accumulate merits for ourselves. Firstly, the irregular movement of molecules in the microscopic world cannot describe the motion of substances in the macroscopic world. In the macroscopic world, Newton's classical mechanics is still correct. If I drive home from 300 kilometers away, maintaining a speed of 100 kilometers per hour, then I can arrive home in 3 hours. This is definite, not uncertain. 5 plus 3 is equal to 8. This is definite, not uncertain. The irregular molecular movement we observe under the microscope is based on the premise that all molecules involved in the movement have equal values and the same molecular weight. Because the molecular weights are equal, when they collide with each other, they still follow Newtonian mechanics, that is, the law of equal and opposite action and reaction forces. So, their movements always appear irregular. But when one of the molecules has a molecular weight much greater than the surrounding molecules, as long as it determines a direction of motion, the other molecules cannot stop it. Its movement is no longer irregular, but regular towards one direction. Even a piece of iron, as long as strong positive and negative currents are applied to both ends, the electrons in the iron with irregular movement will immediately move uniformly in the same direction. If you put an iron rod into a coil and pass an electric current through the coil, the iron rod will be magnetized. From then on, the molecules with irregular movement in the iron rod will move uniformly towards the same direction. Therefore, it can be known that the irregular movement of particles in the microscopic world cannot overthrow the law that all our efforts and contributions are to accumulate merits for ourselves. At a hub railway station with a four-directional railway network, we often see crowds of people surging and passengers flowing endlessly in the railway station. On the surface, these people seem to be moving irregularly, but in fact, each person is walking towards their destination amidst the collision of the crowd. Secondly, let's look at quantum. Perhaps many people equate quantum with molecules, atoms, electrons, protons, neutrinos, and so on. Molecules, atoms, electrons, etc. are all particles, a kind of substance. While quantum is a unit of measurement of energy for a particle, it is not matter. Therefore, it is wrong to use quantum to measure or compare human thoughts, which is a conceptual error. The uncertainty principle of quantum mechanics only applies to the movement forms of particles in the microscopic world. Although the human body is composed of electrons, which exhibit wave-particle duality, it's essential to recognize that graphite and diamond, both consisting of carbon atoms, have vastly different properties. Therefore, we cannot infer the characteristics of diamond based on those of graphite. In other words, we cannot treat the lead core of a pencil as if it were a diamond. The future of every individual can be predicted and determined. When we look at the vast crowd in human society, it resembles the irregular movement of molecules under a microscope. For those who lack faith, have no definite life view, values, worldview, direction, or destination, their future is determined, that is, continuous reincarnation. In times of peace, if someone commits murder, then his future is essentially determined, either going to prison or receiving the death penalty. If someone frequents the casino every day, although the roulette wheel in the casino appears to be a random event, what can be determined is that eventually, those who participate in gambling will lose everything they have. If an official frequently accepts bribes, it can be determined that he will eventually be imprisoned. If someone is lazy and very selfish, it can be determined that they will lack clothing and suffer from poverty. When I plant a watermelon seed, it can be determined that watermelon seedlings will grow, watermelon vines will grow, and eventually, watermelons will be harvested. It is impossible to use the uncertainty principle of quantum mechanics to say, it's uncertain. Maybe roses will grow, and no fruit will be harvested. So, who can escape the consequences of their actions and words? The uncertainty principle of quantum mechanics is fundamentally inapplicable to the issue of human destiny. Laozi's saying divine punishments, though slow, are always sure. With big meshes, yet letting nothing slip through, is absolutely a law of the universe. To understand the cause of past lives, look at what you are experiencing in this life. To know the consequences of future lives, look at what you are doing in this life. This simple statement holds profound philosophical insight into life. Now let's look at the future of Chanyuan celestials. Before becoming Chanyuan celestials, they can be said to be moving irregularly, but when I guide everyone onto the Tao of the greatest creator and the way of life of Chanyuan towards the celestial island's continent, it's like magnetizing the iron rod. I continuously infuse spiritual and mental energy, so all electrons in the magnetized iron rod move uniformly towards one direction, and the ultimate result of the movement must be reaching the celestial island's continent. I shout loudly in the crowd. Who's going to South Africa? Those who want to go to South Africa, follow me. So, some people say, I want to go to South Africa. So, I start processing visas for South Africa, buying tickets to South Africa, packing necessary luggage, and pre-booking hotel rooms in South Africa for everyone. Can these people ultimately reach South Africa? We cannot use the uncertainty principle of quantum mechanics to say, who knows? They might end up in the UK instead. Are the Chanyuan celestials undergoing Brownian motion? Or is their future destination uncertain?